everyone, Alicia McGill here with Math Labs. Today we are looking at Lab 1.2, which corresponds to a Common Core State Standard 6.RP.1, which in the Math Lab book is, in the 6th grade book, Ratio and Proportional Relationships. This is the second lab. If you recall yesterday, we worked with a lemonade problem and we did an exploration involving a ratio table, and we looked at the ratios of water to sugar and lemon to sugar, and we explored some great concepts. But today we're going to look at the meaning of a ratio and the definition, and also continue to work with ratio tables, as well as learn how to write a ratio. Okay, because there's 3 ways in which you write a ratio. All right, these are mathematical practices 1 through 4 that we're going to be working with. And 4, using models, our model that we are referring to is the table, okay? So that's your ratio table. Also, we have pictures of ratios that will serve as a visual model as well. All right, so let's get started. And remember, we're filling out our violet template for our vocabulary. And so the definition of ratio, you should already have filled out from yesterday, because we talked about a ratio and we filled that out so that everyone was clear on what it means to have a relationship between 2 similar things, right? And you know, it could be anything, boy to girl, it could be, you know, schools to restaurants, and it doesn't have to be 2 similar things per se. It can be something that's totally non-similar, like water to burgers. I mean, but then I know you're like, well, they're both food. But it could be like cars to burgers, you know, and those are different. So it's just really a relationship, and we can quantify it as one relationship, one part to the other part. We're going to look at part to part and then part to whole. All right, let's read the lab and get right in. Okay. Let's read the objective. We are at Lab 1.2. I can express a part-to-part ratio and express equivalent ratios, in a table. I have a hard time reading. I can speak, but apparently it's just really difficult for me to read. Math teacher. So here are the directions. It says, write each ratio in 3 ways. 1, using a colon. 2, a fraction. And 3, with the word to. T-O, and I'm going to show you that in a moment. And then make a table to show equivalent ratios and state one of the equivalent ratios. And it also asks us to write the meaning. All right, so what is the ratio of flowers to stars? It specifically said flowers to stars, not stars to flower, flowers to stars. All right, so what we have to do here is count our flowers, which I can see here are 1, 2 flowers. 2, how many stars? Well, you know what happened a few moments ago? I was erasing and I forgot to redraw that. Okay, there's our picture. All right, so 2 flowers, so 1, 2, 3, 4 stars. So the ratio I see here initially is 2 to 4. All right, we can express that 3 ways, using a colon, 2, the word 2 to 4, 2 to 4, and then not a fraction, but like a fraction. This 2 to 4, and this fraction bar is really kind of there so that we can see, like, this is kind of like half, or it takes twice as many of this. It's more about comparing the numbers than it is a fraction. It's not a fraction at all, actually, 2/4. When we look at part to whole, we can think of it as such, but definitely not for part to part. All right? You could think of it as 2/4. Or 1/2, and we'll talk about that in a moment. We're going to reduce this now, okay, to lowest terms. So what I want you to do is think about dividing this picture, and so that you have the same number of flowers and hearts in each group. If I did that, then I would have 1 flower for every, you guessed it, 2 stars. And you're like, oh my gosh, Miss McGill, that's just like equivalent fractions, right? 2 to 4 is the same as 1 to 2. So these ratios are 1 to 2, and then the word 1 to 2, and then of course with this fraction bar, even though it's not a fraction, 1 to 2. All right, then it says, what's the meaning? So we're going to write a sentence using our simplified ratio. And so what this means is for every, we're going to start every sentence with that, and I kind of have a sentence starter for you. For every, and we have one flower, so for every one flower, comma, there are, you guessed it, how many stars? 2. Very good. All right. I hear you out there. I hear you guys all out there working with me here. There are 2 stars, period. Here's a complete sentence of the meaning of this particular ratio. It means for every one flower, there are 2 stars. That's going to help us fill out our ratio table here. Because, first of all, here it is in the table. For every one flower, we can fill that value in right now. There are 2 stars. So that's an easy one here. And then we can go on and add for every one flower. So if I add 1, just like we did yesterday in the ratio table with the lemonade problem, then for every one flower, there are 2 stars. So we're going to add 2 stars. Now if you had 3 flowers, so here this shows 2 flowers to 4 stars, but if we had 3, so if we add another flower, we have to add another 2 stars. So what would we have here? 6. Very good. I could visually show that, for another flower here. We'd have to add 2 more stars, and that would make 1, 2, 3 flowers, and 2, 4, 6 stars. Okay, so these are all equivalent ratios. They name the same quantity, but it just looks different in terms of if we had 2 groups, or if we had 1 to 2, or 2 to 4, or 3 to 6, etc. So, what would happen if you had 12 stars? How many flowers? So you might have to go backwards in some of the tables, and I really want you guys to work together and talk about it, and use that language for every, because I'm forcing you, first of all, to write that one sentence, because I really want to reinforce the meaning of the ratio. And I can tell you it all day, but until you have to write it out for every problem, then, I know it will sink in and you'll have that understanding. You can definitely see in the table, for every one flower, there are 2 stars. And this is a great visual model, right? All about Common Core. The visual model which backs up so that you understand what this means. Okay, that's a beautiful thing. All right, so you're going to work with your partner now, and you guys are going to finish the lab and work through all of the different boxes that have different pictures for you to count and write the ratio in 3 ways, the meaning, and then have fun with that table and really try to fill out all of the values that are missing. And then you're going to extend that further, and there's a couple of focus questions at the end where you have to kind of critique reasoning and justify your reasoning, etc. So there's some really important higher level thinking questions at the end of the lab, and I want you guys to work really hard on finishing those. If you finish everything, you can work on the independent practice. But we're probably not going to get to that, and that's going to be your homework. Remember, every lab has an independent practice. All right, now I'm going to give you about 25 minutes to work with your partner on the lab, and then we will brief. Remember, the part of the lab is L, launch, which I just launched. A, analyze and apply, which is what you're going to be working on with your partner. And B, then we brief, and we talk, and we summarize, and we use that math vocabulary and all of that. So have fun with this lab, and we'll talk again. I'm going to circulate around the room and facilitate if you need help, or I might even ask you a focus question, a key question about what's going on and what you guys are doing. So please make sure that you are talking and using the vocabulary for every, and you can kind of refer to this in the example that starts off in the lab. All right, well, have fun.